Welcome to a new test and teardown video. This time it's an AVO test bridge. I found some information about this AVO test bridge on Radiomuseum, so thanks a lot for that. And it says this unit should be between 1937 or 47. So that is about the 10-year span they think it is made. And they also say there is a possible conflicting age because some of the tubes, they are not dated, or they were not invented when some of the models, they should have been released. So at least some of the manuals or the documentation about age is not perfectly matching with the different tubes. So that's a little bit interesting. I was able to pull this out of the case. That took quite a while. So this aluminium case here is almost too small for the unit. So it grabs really, really hard all the way around. And since aluminium is really, really soft, you can definitely see that many people completely destroyed the aluminium case all the way around in their attempt to get the unit out of the case. As you can imagine, this is really, really old, right? So I want to show you some funny things. So there's a leather strap here, and it's in quite okay condition for its age. Well, look at that. Can you imagine when somebody comes here with their hands like this? So their nails actually removes the paint. I mean, this makes perfect sense because of the location of the missing paint, huh? I think that is a little bit funny. I did a lot of research on this instrument before I started to do this video. For example, I found an online forum called UK Vintage Radio, and there is many threads there about this AVO test bridge. So I found that really interesting. So it's a big thing in UK to collect AVO and to restore and repair them. And in that group, I found both service manual, restoration manual, and all that kind of stuff. There's a really, really good manual written by Ian Wilson, radio amateur call G1JXP. So I really like his manual, and I will use a few pictures from his manual in my video here. Unfortunately, the good Ian did not put in any kind of contact information whatsoever in his really, really good PDF file. So that is a shame, because I think I got a few interesting pictures for him to have for his collection, but no contact information. I can't share anything. Well, just bad luck. Other things I found with my unit here is, see, we have a mechanical problem here. This dial is not moving as it should. See, something here should turn around, and that does not happen. The on-off switch feels alright. And this is the power factor potentiometer. And that will be the different modes of operation selector. And that one feels quite alright. It goes a little bit tight. But I mean, so far, so good. So about this unit, it is a bridge, obviously. I think you have already figured that out, right? And then there is a meter here. So minimum output on this meter, that indicates balance. And balance in a bridge, that is when you have equal voltage on the left and the right side of the bridge. This is also explained really, really good in Ian's PDF file about the bridge and how the bridge in this instrument is implemented, and how the difference, the center point of the bridge goes to a vacuum tube amplifier, because everything here is working on AC mains. So the AC mains signal, of course, on a secondary winding of the transformer, that is our signal generator, so to speak. So it uses, of course, AC, and that means you can measure capacitors or inductors or components like that, as well as resistors. All you have to do is compare. So that's quite nice. In the external compare, you put in a known value of whatever here, and then when you put on exactly the same component on the other side, you will have a balance, and then you have no indication. And the difference, if this one is a little bit higher or lower, then you can compensate for the balance and then see how much they differ. And if there's current going, I think this is, there's liquid current going, then this lamp should be lit. This is a neon bulb. If we look at the internal parts, there are a few different models of this unit. As you see in Ian's PDF file, we got 3 main versions, and my version here is exactly like his L63 version, and I think they call it the L63 because of the tube here is an L63, right? We got some other really interesting components of this unit. High voltage, the anode high voltage for the tube is 200 volts coming from the mains transformer, and it goes to this really, really long selenium rectifier. So in here you have tiny little discs of metal with selenium coating on them, and this creates a very long and high voltage rectifier. Other things I find really interesting in this design, that is this part here. So this is called a W2, and that will be is called a westector. Westector. It's a copper oxide diode. So that one is definitely a new thing in my lab. So what the heck is that funky diode doing in here? And that rectifies the AC signal after the amplifying tube, and then it drives, of course, the meter. Yeah, because the meter needs a DC to, that's how it is, of course, right? So we need a diode of some sort, and that, because this unit is so old, they're using a very, very special diode. I think that is so funny. Yes, and it's a lot of brass fittings and all that stuff. Yeah, it is a little bit funny how it's made. Oh, we got some DW, whatever that means. So I'm a little bit curious to see if I can fix the mechanical problem with the dial here and here. It's not really like it's not connected to anything. So that is something I will have to deal with. You can see there's a switch down there. I believe that will be an on-off switch or something like that, right? It was repaired a little bit. See, we got some little glue stuff. What is that doing? Funny looking wire that was cut. I don't know if I'll... Oh, we got another wire. So it's connected to 2 different things and then twisted like that. It could be several things. It could also be a variable capacitor. That is often done by twisting wires like that. It could also be some external voltage, and then the wires, they were just cut for whatever reason. We got a little bit of nasty. See here on the nickel plating of that component here is a little bit corrosion, and Maybe we should see if we can see the tube. Yes, look at that. Beautiful. And that neon indicator is just wonderful. So on the back side of the case we find full working instructions. My model here is a little bit tired, as you can see, but luckily I find a really good quality reprint of this in Jan's PDF file. So I will put the working instructions here from his PDF file. So thank you very much, Jan, for that. I hope you're okay with that compared to mine here is definitely an improvement. So I'm still dealing a little bit with some of my mechanical issues. So here is the scale, and now listen. Ooh, it goes real nice and smooth. And I lubricated this with a little drop of oil from the front and from the back. And in here you can see the little switch. See, clickety clickety click. So, and the slider you have here is either to the left or the right side, right there or there, right? In combination with that switch is also using those two holes. See, on the back side of the scale, there is this little piece here. It's a little bit worn down. You can see here. Look at that. It's been moving a million times. It's me who added a little marker here, and I also added a little marker on that one, obviously, because I wanted to be able to put the scale correctly back again. The reason for those rather large holes here, that is for calibration, I would assume. So you put this here and see, there's a possibility to do a little bit of fine calibration here. So you just loosen the 3 screws on the top of this washer here. So here's this little brass washer that goes like this, and then you can fine tune the adjustments. And I will try and assemble all this and hopefully get it up and running. And I'm going to assemble this again. I want to show you this tiny little, see, there's a little groove here or something like that, right? And this holds this plastic with the line. And the only thing that holds it down is the back side of the knob. And then this is made nice and fine, huh? So this one goes here, of course. And because this shaft is just round, you can see that the lines it made. And no matter how much you try and tighten this, you can of course crack this and break this. But what they should have done is they should have grinded a flat edge on this shaft. And this way the knob will sit real nice and fine. So I think this is one of the improvements I want to do, is I want to make it nice and flat here. Just exactly where you have the two lines there. And then I'm sure the knob will be perfectly fine. I think that turned out to be really good. Look at that. So I think I'm ready now to do the first power up test, and the most simple test I can do with this instrument, that is to try and use its voltmeter function. And if you read a little bit here in the explainer, it says use of valve voltmeter for external voltage measurements. And this is of course AC volts. Okay, so what we have to do is we put the dial into click position V and the selector switch to V. And the voltage to be read should be applied to the terminal external. Okay, and look at that. The terminal marked with this symbol should be earthy. I love it. And the voltage is indicated directly in volts. I think it should be RMS volts, right? Because it's AC, and it also says here in the meter, if we look really careful, it says external volts in RMS. So far, so good, right? So, and then we just put this into on, and we turn on the variable mains. We just go really slowly up, and we are now at 100 volts. It's using 1.5 watts, and that means I am not afraid to go all the way to 220. And I will of course look really careful. Look at that, meter is going up, and then is it staying up? That is not good. See, I don't have anything connected to it. So we have some sort of a leakage. It's not supposed to stay there. Can you see this? So that means the diode detector is not working. You can even see that, because this is how this thing works. I'll just leave it on a little bit, and then I will start measuring on the schematic. I will measure around, and I will look a little bit more on the schematic. Yeah, that's what we're gonna do. So here is the schematic, and we have a little problem. And I, of course, figured out what is the problem, simply due to the schematic. And here we got the calibrated dial. We have a V or an L indicated here, and that is the 2 click positions of the dial. And then there's also this switch here, and then this is also affected by the position of the dial. Obviously, it says we need to use the external connectors, and this point here is our earth. So we also need to have this little voltmeter enabled here. So this one here is our voltmeter, okay? So that means input to the tube is now connected to the V for voltage, and that goes to our external input. But I took my ohm meter and just verified this earth connection is not connected to chassis ground. And chassis ground should be connected to that point, because of this V connector here should be in that position, and that did not happen. And then I tried to turn around on the dial, and then I actually had it working when it was like this, or here, right? But it was not connected in exactly this click position. So all I had to do was to remove the knob and loosen the 3 screws, move the dial, the scale a little bit, and then tighten everything up. And now when it is in this position, I have the correct ground. So now let's try and play with this. Now we have the unit warmed up, and here is my 1 volt of input, 100 hertz, and let's see what happens. It goes to exactly 1 volt on the readout. Aren't you a little bit impressed? See, this is 1, and let me remove the signal, 0 to 1. They did explain in the manual a little bit about the voltmeter not being super accurate or anything like that. So this is 100 hertz. Let's try and give it 200, 300, 5. Okay, this is 1 kilohertz, still perfectly fine. Okay, let's try 1 volt. So that's 2 volts. Oh dear. And now it goes absolutely crazy. So this is reading 5.5 or something like that, right? Let's give it 3 and 4. Okay, so definitely 5, 6, 7. Okay, okay, so that is how it is. Obviously, this fantastic copper sulfate diode or what the heck that is. Not exactly super duper good or linear or anything like that. But normally this unit is only used as a bridge, and in the bridge is only a matter of minimum indication. So I think that is the feature we want to experiment with. I'm of course trying to use it for measuring resistor, and here I go with a 1K resistor, this tiny little size here, and I put it into R1, and I believe now I need to use this point over here, should be the unknown resistance. And see, in R, it says here on the outer scale, R is 1 right there. Okay, so when I put in this 1K resistor right here, it goes burning hot immediately. So I mean, no, that's probably not the way. So what the heck am I doing wrong here? Or there's definitely something wrong with the instrument. So this is something to investigate. So I think I figured this out, and it is also explained here on the back. It says to measure value of unknown resistor, it says using selector ranges R1, 2, 3 and read the calibrated scale. So for resistance 5 ohm to 1000 ohms, we have to use range R1, and I wanted to do that, and that is of course at too high power for my tiny little resistor. So what I can do is I can use the next range, that is the range 2, and then it will be able to measure from 1000 to 100,000 ohms. Okay, so this is of course at the end of the scale here. Now I am in range 2, resistor 2, and look what happens now. Here's my 1K resistor. It's difficult to see, but here it is. So let's try and move the dial. See, whoops, and then see, we have definitely a clear peak. And here we go. And then you can read the value on the meter. And here it is, of course. This is a little bit over 1K. And I think if I move the screws again and fine calibrate, then I will be able to get exactly 1K on the readout. Before I touch anything like that, I will try and replace the resistor with a 10K. And then I think this peak should be about here, right? Because this is a factor of 10 higher. So let's try and see if that is right. Now we got a 10K resistor, and we are in this area here. And look at that. Haha. It is actually quite impressive the way that it works. This potentiometer is really, really good, and the readout is good. And there is also a nice mechanical feedback feeling when you read the meter and how much you have to poke around here. I mean, this is a really, really good bridge, to be honest. I am impressed. Oh, I mean, this thing is from 1937 to 47. That old it is. And it really works. Look at that. So, I'm quite happy about this unit as it is. Yeah, it's not super good when it comes to capacitors. I think some of the capacitors in the maybe they are here, or I don't know exactly where they are located, but they're probably a little bit leaky or something like that, and this can explain why it is a little bit off on measuring capacitors. But other than that, it's more or less still working. Yeah, see, we got some really nasty old capacitors here. There's probably a good reason to change that one. That is nasty. Well, so thank you very much for watching. I hope you had a little bit of fun. Please like and subscribe and comment and all that things. And yeah, tell all your friends to come by too. Bye bye.